In this video, we're gonna be discussing about Sender Policy Framework. Sender Policy Framework, also known as SPF, is a type of a domain authentication that helps preventing sender address forgery. Basically, it checks the domain under envelope sender address or the return path and verify if the sender IP address is permitted to send an email on behalf of the stated domain. Let's take a quick review of parts of an email for us to further understand the SPF mechanism. Like a physical mail, an email has an envelope where the first three commands in an SMTP transaction from the client side is initiated. On this case, we have the extended hello greetings, the mail from, and the RCPT2, which comprises the email envelope. In a physical mail, the details on the envelope will be the one to be followed by a postman for the destination and the return address in case of undelivery. This is true also for an email. An SMTP server will check on the envelope header for the destination and the return address. Opening the envelope, we have the message. In SMTP, the message is denoted by the data command from the client. Inside the data command, we have the message header, which basically the one that can be seen by the user. It is commonly comprises of from, to, and a subject. The takeaway on this is that the details on the message header is optional. So you can still send an email even if you choose to leave it blank. However, some SMTP servers may be configured to block such kind of email. And of course, along with the message header is the body, which contains the message itself. Just to repeat one more time, we may refer to the envelope header as the one followed by the SMTP servers, while the message header, on the other hand, is the one seen by the users. Another thing to take note is that the details on both headers are not required to be the same. In a delivery point of view, the envelope header is the one that matters. Okay, so let's move on and discuss about SPF configuration. There are two steps for the configuration of SPF. One is publish an SPF record. Another one is configure SPF authentication. These steps are actually independent with each other. In fact, it is okay to do only one of it. But of course, it is still recommended to do both. Now, for the purpose, publishing an SPF record is for the security of the receiving SMTP server. That means any SMTP server that will receive an email with your domain can do domain authentication because you have provided them such SPF record from your DNS. In addition, it will also help prevent your domain to be blocked by SMTP servers in case an attacker utilized your domain for spoofing. Next, we have SPF authentication. Basically, when SMTP server has an SPF authentication enabled, when it receives an email, it will check on the domain from envelope sender address and query an SPF record to the equivalent DNS server of the stated domain. So this feature obviously is for the security of your own SMTP server. Now let's see how mail flow works when there is no published SPF record from a domain. In this example, we have sim.com as the victim domain. The receiving domain is trend.com, which is basically a victim also on this scenario. And of course, we have the attacker that will try to forge or spoof the sim.com domain. And sim.com not having any published SPF record. Let's see how it goes. First, an attacker will establish a connection to trend.com, of course via its firewall, and will be forwarded to the email gateway via port 25. Then once the attacker established a TCP connection, it will start the SMTP hello greetings and then the mail from command, which states that the email came from pete@sim.com, which is a spoofed sender address. Trend.com having an SPF authentication being enabled, the SMTP transaction will pause from the mail from for a bit, and Trend.com's email gateway will get the sender domain, which is, on this case, the sim.com, and will query an SPF record. So first, let's say it will go to its internal DNS server. The internal DNS server having no cached for this domain, sim.com, it will go on the internet, okay, to Trend.com's external DNS server, which commonly an ISP. Then go to the DNS network until it reaches the sim.com's external DNS server. Now, sim.com receives the SPF record request. Of course, it will give its response that there is no record to the Trend.com's DNS server. Okay. So it will go back to the internal, and then the query response will be received by the email gateway. From here, email gateway identified that there is no SPF record available for sim.com. With this information, by default, the email gateway will accept the message and continue the SMTP transaction from the attacker. Okay, so it will continue with the RCPT2, then the data command until the message has been transferred to the email gateway. Now, once the email has been accepted from the email gateway, it will be forwarded to the internal SMTP server. And when the user tries to access it, it can see that the email came from pete@sim.com. So the user who won, without noticing that the sender address has been forged, might possibly send a reply on the message. Now, what if the sim.com domain published an SPF record? Let's walk through the same scenario again. The attacker will establish a connection to Trend.com via firewall, then to the email gateway. Then once that TCP connection has been established, the SMTP hello greetings will start, and then the mail from command pete@sim.com, and the same thing, email gateway won't respond to that command immediately, so it will query first to its DNS server for the SPF record of sim.com. So that will go outside to the internet until it reaches the DNS server of the sim.com. But this time, sim.com has an SPF record on its database, which is the txt record v equals SPF1 mx-all. For this record, it only means that only listed IP address or addresses for the MX record is allowed to send an email on behalf of sim.com domain. So on this case, the MX is mail.sim.com. So let's say we have an equivalent A record of mail.sim.com as 123.123.123. So basically, there are 3 records that sim.com's DNS will provide to Trend.com. So that's the SPF record, the MX, and the A record equivalent of the MX. Then the response will be sent back to the Trend.com's external DNS through the firewall to the internal DNS to the email gateway. Now, from this record, email gateway know that the only allowed sender IP address on behalf of sim.com is 123.123.123.123. This IP address will be compared to the sender IP address of the attacker. So this established connection has an IP. So let's say a different IP, that's 211.211.11.211. Okay, that will be compared to 123.123.123.123. And since the IP addresses are different, the SPF authentication will fail for this message. Hence, the SMTP connection will be terminated. So the takeaway on this example is that this IP address here is the only allowed IP address to send an email on behalf of sim.com domain.